Hi there, I'm here with Vito Žuraj. Today I would like to explore with him his work of life, right? It's the patch. Isn't it so? Is your automaton.
Exactly, something like that. It's a personal artificial assistant, but it doesn't work without me. It is a part of the flow. It doesn't control me, because sometimes it's like that the algorithm is so complex that it leads you some way. So I'm still the one with the tennis racket in the hand. So this is the ball.
When we started to know each other, it was year 2013.
In Salzburg, right?
I think so. That was my academy time still.
Yeah,
a little before then, I think, yeah. And I was really fascinated by it was not demo version, it was already functioning rotor and all this stuff. You probably will show today how it works like. And can you briefly just introduce how you got the idea that you need that as a composer, and where did it actually took you in a way, right? It actually took you somewhere, so you built your own instrument as a composer. And what was the initial impulse? And
that's actually very interesting mentioning that you say in the instrument. That is maybe the most accurate description of what it actually is. When I started to study composition in Germany, it was in Dresden, 2002, I think. And this was my contact to the electronic music and to the programming. I haven't programmed before. So I got some basics in Max MSP in Dresden. And I had an idea back then already that with Max MSP I can prepare certain structures which I think are interesting for my instrumental work. And how would it be if there are some chords which I can then transport to a visual interface, like transport them, for example, into the finale score. So back then I first did some experiments to use the now already dead finale, because it's being discontinued. Very pity about that.
Long live. But
still it can it can make possible to transport live 128 channels, 128 MIDI channels at once. So I don't see any other notational software which does that. So I build a bridge between finale and Max MSP, so that it can play directly into finale in case, and I can see the score. So back then, 2002, it wasn't possible. So I was like developing it, and actually 2010, I finished the first functional version of my patch, Max patch, which I called M metrics, like for MIDI music metrics of different algorithms, which make it possible for me to transport very complex rhythmical and pitchwise structures. I can see them more accurately and work with them. I don't play with numbers, because if the Max MSP patch from the outside, it looks nice, but if you look at the programming, how it looks behind. My point was to avoid working with numbers which would interrupt my creative process for the actual sound of the piece, for the basic sonic idea. Because back in the algorithmic music, in the history, back then old machines need time, and you get every printout just numbers, and then you had to convert them into music. And very often this kind of music wasn't very interesting, because you had to fight with numbers so much that you forgot about actual meaning. You would like to compose too many numbers. So I created the bridge so that I control all the numbers anyway, because I have programmed it, but I don't necessarily want to work with numbers when I'm creating a flow of music. So behind that, if I if I have, I don't know, a couple of
you have preset matrix.
Yeah, I have some presets here. If I don't know, look at the numbers of some.
This is what
chords.
Is the chords list.
Yeah,
is
that's the chords
definitely
list,
the tuning, right?
These are pitches, yeah, and this would be the time. I mean, this is now very simple, like triplet, like quintuplets. I can do a lot of different things here. You know, some ritardando, and then I got a bunch of numbers, which would look like these. You know, and when you are actually when you want to, I'm going to copy all these numbers in a text editor, just to see with what you would be dealing with. So imagine having to work with these numbers and actually, composing music. It's just, I think it kills creativity, natural flow of music. So this is in the background. I don't need to know about this consciously because I have programmed it. Yeah. And this would be automatic conversion to pitches, which I would be sending to Finale.
And the protocol you use is MIDI.
Exactly, that is MIDI export from MaxMSP over MIDI bridge. Like I have internal MIDI ports, which works very well on Macintosh. I have 8 ports, 8 times 16, so I have 128 channels. It is normally enough for even very big instrumental force. Yeah. So as long I didn't need more than that.
Choir and the orchestra.
Yeah, that was one time I had kind of choir and orchestra, and I almost used everything of that. But it was enough. So I don't think that I was going to compose for 4 orchestras, 2 choirs. Maybe in the future. So this is how it looks behind. Yeah, that's crazy language for somebody who would just think about music and trying to avoid numbers. But if I go on and show you how it actually is done, let's do a sequence of chords, and I'm showing you how it's going to work with this bridge. Here is the field where I would put instruments. I'm doing a small demonstration for the winds. So this is an ancient version of Finale. It's 2011. So don't ask me why. I mean, the reason is that every later Finale version was difficult to work with scores on very large format. It means division of strings. Yeah. You would need kind of, DIN A2 or DIN A1 sized score, and having so many stuff systems to display, it would turn pages very slowly if you work with Finale from 2012 on. Some newer versions now, like I think the latest would be faster, but not in between. So therefore, I stayed with that version. I optimize all the macros. I don't use sound in Finale. That would be a trouble because it's too old. But I don't use it anyway because I think as a composer I should imagine sound in my head as well. And this is now the demonstration. Like we have winds, 2 flutes, 2 oboes, 2 clarinets, and 2 bassoons with some changings, doublings to bass clarinet and contrabassoon, which I would enter in my field here. So we have flute 1, flute 2, oboe 1, oboe 2, clarinet 1, and there's a bassoon 1, then bass, clarinet, and double bassoon. I'm going to type it wrongly just to see what happens. So if I put anything wrong, the system would say, "Okay, come on, check it again." And now it's right. Now it's okay. And so now I set these 8 instruments, and I have a couple of input modes. So that would be kind of the normal one, and I have as well the quarter tones, or which I like to do is some spectral. I have like 8 voiced chords, And I'm going to...
And you are playing by one key.
Yes, exactly. I'm playing just half step is, let's say, one overtone more. So
I must direct the camera so that it's going to be really fun to see. I think you can see that, right?
Yeah, of course.
You can take one tone.
Yeah, but let me show something else. So if you would just... So... So basically you can play more than, but if I want really to structure it and I type here like number 2, so it plays every second chord, now in 8. Or like I say, it played every third chord. Then it would be like... we can work with that. And I'm going to play kind of session of this. This is a record button, so it's going to record in a session. I want legato chords, and I'm going to remove out of range notes because double bassoon is not going to play very high. So let's see how it's going to work on that. And we see simplified rhythmic structure, which I can play back. Just a moment. Why doesn't it work? Some trouble. There's always something wrong. Yeah, because of course I did a mistake. Like I have 8 chords, and of course I have to have 8 because I have so it was
8 instruments.
8 instruments, yeah, exactly. So now they are not going to be fine. Let's not try.
And now you put a record button, and then you can see the...
Yeah. I can do it once more, so it's clear.
No, it's really clear. It's really clear now. Yeah, I can see. So you can play back what you just recorded.
I just play it back, and if I like it, or if I just want to see how it looks on paper, I would say now let's transport it to finale. And this is a bridge which works now. I don't need to see these kind of numbers now. You know? This would be normally you would need to manually convert this. I would show exactly the numbers which I just generated. And when building musical form, it doesn't really help. No. So this conversion happens in the background. I have programmed it long enough so that it can make me happy now, doing by itself. So let's transport it to finale. This is going to be like that. Exactly. Do some minor adjustments. These instruments are already transposed. So as you can see, I decided to use a quadrotone raster, and all the quadrotones are correctly displayed, and instruments are also transposed, like B flat clarinets. So I can see exactly what I have composed here. I see it in the score, and then I can work as a composer, not as a mathematician with any just with numbers. That's only one thing. Let's experiment with this a little bit. I'm going to save it. I have this simple preset list here, and I'm going to use this row of 8 voiced chords to play around a little bit. Okay, now the rhythmic structure is kind of accelerando and then ritardando. Let's put it like stable. Something like maybe at half notes, no? And let's do some rhythmical transformation, maybe some arpeggi. Yeah?
It quantized all the rhythmical
Yes.
structure. It kept the exact.
Yes, exactly. So I just said, okay, every chord is going to have a duration of a half note, or maybe everything has a duration of a quarter note, and then I want to make some
Slowing down.
Exactly. Or some even you can see how it looks differently. Let me change like that. So now I can see better. I think I just misclicked. So if I go here, you can see that it goes extra around. But now I wanted to do some experiment. You will see what I mean with arpeggios. So now each of the chords is going to get some. Let's make it steeper. And let the first chord be like tutti.
No, wait, those sliders. I see the sliders. These are fun part. So you can basically make second one longer, third slower.
Let me make it that. So and then you see how they move down below. And I can say, okay, like these are going to be other way around.
Counter it means the.
Yeah. The second is
inversion.
Kind of from exactly. So this is going to be down. Let's move the.
Imagine that writing that by hand.
Imagine writing that by hand. This may be even more interesting to. Let's make it like that. No, let's make it like really slow at the end. Of course, I individually can say, okay, the first is going to be long a little bit.
What?
Yeah. Maybe the second a little bit longer. Let's put this one a little bit that. Everything can be individually. And let's look how this looks on paper. So one click, it transports. For example, it's maybe not the most artistically interesting, but nevertheless it works.
As an orchestra musician, I must say, when I see the score, as a conductor, I would probably see something different. But when I see the score as an orchestra musician, I can imagine that it leaves still the place of human mistake.
Yeah.
And I can imagine that it immediately sounds otherworldly, and it immediately sounds. It can be delivered absolutely as a musician from the orchestra. You can see and how your own playing can impact the score, which is, it's of course immediately different from most of students play to learn. But this is absolutely deliverable. You can print that as a score, and
yes, you can play, because I'm actually working with rasters of like I say, the most is the division by 4, 3, or 5. As a bass, I work with values divided by 4, by 5, or by 3. So triolas, sixteens, and quintuplets are the values you would be able to play together in the orchestra pretty quickly.
Yeah.
So no kind of 7 tuplets with breaks in between or 13 tuplets which can
very hard. Yes. Very hard.
Yeah, it's a very idealistic. If you have the entire section which wants to be played together and kind of works, that scores which looks like that pretty easy to realize in short rehearsal time.
Very short.
Let's see, like that. So it's now it's kind of 8 bars or something like that. That's playable. And then of course, when I would be working, then it's my job to assign dynamics, for example. That's an easy thing, you know. Oops. You know, and articulation and anything else.
The simplicity of finale.
Yeah, exactly. And clefs and stuff. So this is kind of raw. But imagine having this idea, the time it would need you to spend to get this kind of picture. You know, it would take hours. And doing a lot of mistakes as a human being. So that's the bridge which makes me possible to work with notes very quickly and try it most times. So I can make like 30 tries, even more than that, and then decide which I'm going to take. Not to do just 1 or 2 tries and then spending so much time with numbers that my initial idea would be even forgotten or transformed so that it wouldn't work anymore. So basically this pitch rotor would be the first module I programmed, and this the basic things I programmed when I was still in Dresden. And there's another algorithm, but this one, my idea was, if I, you know, being taught as a composer about the 12-tone system, then you have like, you know, Umkehrung and Krebs, like inversion and. But that's basically if you have a tone row, and then if you like make a inversion of it, then it's basically you have turned it 180 degrees.
Exactly.
But what about other possibilities in between, from 1 degree to 179? What now? Explore that. So let's do some easy scale, yeah. So you can see it here, and I can play that just for. And this is an axis which I can turn here. I think I have it. I have it here automated. Yeah, of course. That's good. That's good.
That's fantastic. It looks
always nice. So if I play it now, then just listen and. And if I like this, if I like to play around just to see what's going to happen, I'm going to I can record. Let's record it for some just non-specific instrument. So if I choose, like, because you're playing a flute, let's put the first flute. But then if I put a Z in front of it, it means it's not going to check the range. It's just going to record everything. Otherwise, the algorithm would check the range. If I go too high, it would put everything octave lower, and if I go too low, it put octave higher, so that I see that something was not right. Yeah? But here is going to record everything. If I decide to play with that, let's do that. So I'm going to record now everything I'm moving with this rotor guy. I'll just play around a little bit with this rotor machine.
I did record the timings.
Exactly. Yes, it did. So I will put it in legato. it quantified.
Yeah.
So that it is
2 quarter tones. Right?
Exactly. So as well rhythmically quantify so that I can see it in the score. I'm going to show us something else. If I transport this here, then you see. This is maybe not the most interesting material, but just to see how you can play around. So something like that you would be able to maybe to play or not, just to see what is happening. Yeah. Now this is kind of limited rhythmically, but if I record, I'm going to show us something else. Let me save this. So I can switch off the quantization. And then I get completely crazy. It's going to be exactly as I played. Yeah?
Okay.
So now I'm going to play again. Where is this like that? So. And now this you're going to see exactly as it was. Sorry. Yeah, just the dots. Yeah, this is not going to affect legato. So if I would have some other exactly as I played. Now it was the same because quantization is off.
Yeah.
So if I want to export exactly values to maximum speed and play it, to MIDI file and play it with it again, if I would transport that, I would get a mess in finale.
Yeah.
Because no, it was not made for that. So I think it's going to look crazy. But this was not it's not meant to be.
Yeah.
So. Sometimes if you work with a software and to get stuff like that, you can lose your mind. So now you can see this is without the quantization, and this is with quantization. So you see the difference.
Playable.
Yeah. This could go into much more detail. I just need to adjust the rostering which I have here, and there's so many different possibilities with this patch.
Well, the rotor is one of them. I was really impressed when you showed me. Just at that moment, I realized that there is something really, really vast to this process of making your own instruments, and this is, for me, it reminds me immediately that first feeling, which basically opens worlds of inspiration, of course, to do what can be done. Of course, I'm working with real time in Max and getting to my own instrument to make the patch which works in real time. But this is an absolutely crazy model. This fantastic. To work with scale and precision, you can achieve it.
I as well did like it is in Pro Tools. You have the automation for every bit of controlling. So I have programmed it here. So I have this automation. So every button, everything here can be automated with the scale. How it moves.
Crazy. This is crazy.
And this. I used it much more before, I must say, because afterwards I did some other modules, but with 5-6 years ago, when I did some chamber pieces, I used it a lot, and it helped so much. So I have this.
Which pieces did you do?
I think actually more like, let's say 2012. Oh, it's more than that. It's like 13 years ago. I used a lot of this, so I have this kind of a lot of different buttons which would turn by its own, and
time, yes, time duration.
I don't know if it still works if I press like T. No. Yeah, basically it would take. Now it's crazy to explain because I didn't know the new session, but everything is controllable. What is here in this control panel can be controlled with time with these scales. with these graphs actually.
Yeah, graphs, yeah.
Graphs, yeah. So much more to this patch, which are, microtonality anyway, and then I have some external modules which can be open at the same time, and they are being, let's say, controlled by the patch, and I can import the values to this patch and then export it to Finale.
I see that the MIDI signal, it's not quite MIDI, so I just presume you did it in the way that Max allows to act with MIDI devices. The fineness of control is not defined by MIDI 0 to 127, right?
It is actually.
It is,
yeah,
but is it acting like accumulating the data you are giving in? Because you have the rotor, which is
this kind of
which is 360.
Yeah.
So how can you? What is the finest gradation of the turn of the knob?
This is one degree here.
Exactly.
Yeah.
And it means that you are accumulating the message of MIDI that you are changing something at one. Right?
Yeah.
Because otherwise it would be just limited to 128.
No. It's just this button just tells him 1 plus or 1 minus, nothing else. And then 127 is, the piano has 88 keys, so it's still within. But if you work with quatertones, that would exceed that. Yeah. Then you would need 176 values. So I have to split them on 2 channels. And then for the second channel, I would specify the pitch bend. Then I can hear like quarter tones. So every quarter tone, which is like untempered, would go to the channel 2. Or if I play, there's still more to it. So we have seen so I have different inputs. So the standard input would be kind of,
MIDI.
So just semitones. And then the quarter tone. Which you can hear and see with the red ones are. So if I'm not happy with that, then I can go to 8 tones. So the entire system is programmed with 8 tones.
Mm-hmm.
The only thing is I don't use it really, because I think as probably you will agree with me as a player that it is kind of too crazy. If you want to, you can be very specific, but it's very difficult to demand from a player in orchestra to be, like I say, with the other guy. I have different input possibilities for my patch. So the standard would be kind of diatonic, chromatic, and for the elaboration, of course, the quarter tone. So then you can see at the keyboard that everything which is red. The quarter tones, if I still need more, then I would switch to 8 tones. This you can see with green. Of course, this is of limited use, because as an orchestra player, you know how it is. If you get a score and then you get a bunch of 8 tones to play.
Hard.
And if the composer wants you to be in the same pitch with somebody else in the orchestra, who is sitting 10 meters away, the same 8 tone. If it's a harmonic, okay. Mm-hmm. If you have the same instrument, but if not, it's going to be out of tune.
Out of tune.
For example, if it's too fast to play, then it's kind of illusion. My entire system is actually programmed to export 8 tones to Finale, but I have never used it because I can use it as a separate color. Sometimes you need it, but for me, just too crazy. But I have thought maybe in the future I'm going to need it, so everything is programmed for that. But I was actually used to compose just with quarter tones. It is still enough difficult to play if you want to be exact in tune. So I'm careful with microtones because you can hear microtonal structures if you let time. If there's a lying note, and then you can perceive how it correlates to another note which is played parallelly, and then you can hear, oh, that's something different than tempered scale. If it goes too fast, you have to have the pre-programmed or pre-tuned instrument, like differently tuned piano or differently tuned harp.
Yeah.
Harp is maybe the easiest because it goes fast to tune differently the strings. But like to have different fingerings on woodwind instruments, or of course strings can finger everything. But having a quarter-tone, something between E and F, so they are so different in interpretation what it actually is. To have it exactly on tune, you know how it is.
Yeah.
So it requires a lot of experience. But I'm working with this kind of microtonality in this patch. I have also scale input, so I have different scales. So this now is kind of normal. If I can say, okay, now I would like to play with some chords. That would be another possibility. I can put some crazy multiplication to it, and then it will sound even more different.
Reflecting of one down, or can you make the negative multiplication?
And not negative.
0.89.
Yeah, so to be. I can do it much more, but then it's going to go out of range and be really crazy. Or if I go here like 1.3, it's nuclear. But you can do a lot of things. So if I play like with minus here, then you can get scales which cross each other down and up. So it can be very interesting. And this is no limit. You can have like 4 voices in a chord. You can have 100.
Negative harmony.
Negative harmony. And while creating like sessions, let's create some. Let's do something a little bit crazy, okay? So I'm going to switch to auto mode. So he's going to choose whatever I wish, and I will. Let's go to the input of overtones, and I will do like a lot, like heavily voiced chords, yeah. So like 28 voices. It is just for the sake of experiment, yeah. And if I record that, this has no significant artistic value now, but just to display what you can do with that, let's record some crazy this, or just for the sake of quantity. So just a lot of chords now, but it's still not. Now 62 chords, which have, it's just crazy. I will just put them in some simulation.
That's what I call black MIDI.
Yeah, but these are like 62 28 voiced chords, and see how much of the actual memory of the patch it takes. So it takes 1.51% of the possibility how many chords I can record, and the least length is like 11%. So I can do much more of that. The least would still be significant. So let's take a look. How much? Every tone has like 4. Every tone has four values. So which is, I'm going to show you. This is going to be a fairly big list. So
wow.
This is the list.
That's a big one.
So every chord has a when it starts. So the first starts at 0. It is I use the value of 600 for a quarter, which can be visible here. 100, so 600 is the quarter, 1200 is a half. why I'm using that. Because OpenMusic uses 1000 for quarter. Because for the computer it's easy to divide. But I'm a human. I have to see this when I'm composing some. 1200 is a figure I can divide by 3 and 4 and 5 without getting any float numbers. And for me it's very easy to see. So if they are triplets, I see them that they are like 1200 divided by 3, so I see 400s or 800s. So I know that's a triplet. Otherwise, I would have like 3 dot, and then it's difficult to read. Yep. So back to these numbers, that would mean 60 divided by 4. So this is 16ths now. So the first entry, the first chord. Sorry. The first chord has the entry of. It starts at 0, is 150 items long, so it means 150. It's a 16th, and the next value starts and at 150, so it follows directly immediately after. And this is the code for the pitch. And so the last 3 numbers are the channel. So this is the channel 1.
So this is channel 1,
yeah.
So it's like a straight tone, not the quarter deviation.
Yeah. Exactly. But this is the first pitch. The first in the, so there would be the second one. It's the same. The chord is the same on the channel 1, and then you see if you read all these values through, you get the ideas. This is in the line. But I don't want to read that, so this is the computer's conversion. And then at the end, if I would like to transport those 28 voiced chords into the finale, I would get a pretty accurate picture of that.
So you build that future-proof space for more resource, time-wise and material-wise, so you can pack theoretically any possible combination, and that's also, then you can also work in a subtractive way to like carve things which work. That's a neat like engineering mind of the scratch is it's really, for me it's fascinating. Absolutely, it's I can that's why I actually decided that if we get together to show this work of yours, just to pass by that feeling that if you are stubborn enough, if you are inspired enough, you can build things which will absolutely blow minds. And this it's in our time where artificial intelligence starts to steal our jobs. I mean, right?
I can maybe show how the end result looks. I would normally build a score from small chunks of that. So I will put, this is the violin concerto I'm just composing, and let me go to the page view. So I hope that's commissioned. This is WDR Symphonieorchester with Isabel Faust. It's come in 2nd May in Cologne, and I have composed some structures for the brass, which play harmonics in a very structured way. That is the score of the violin concerto I'm just composing. It's commissioned by the WDR Symphonieorchester for Isabel Faust on the 2nd of May this year in Cologne Philharmonic. And I'm going to show you one structure. I think it has to do with this principle I just explained. So these are brass instruments playing overtones. And it sounds like a carpet of spectral sound in the background, very very quiet. It's kind of pianissimo, and it would take a long time to write this per hand. And then I have 4 French horns, 2 trumpets, 2 trombones, and so in total 8 brass instruments.
It's like a lake.
It's like a lake. Exactly.
With waves, amazing.
And then I just defined starting points of instruments. So this is starting points for a trombone, then comes the fourth horn, then the second trumpet, then the first horn, then this first trombone, the third horn, and so on. And this is enough time for them that when they start playing, that they can play once up and down. And I have a couple of different speeds, so sextuplet, quintuplets, and sixteens. So it sounds like different waves. If I had all of them playing just sextuplets, you could hear all the pulse, but I just want that it swims a little bit. And then I fed my algorithm with that idea. So for 8 instruments, with the spectral rows. So because it's in the basic idea is being in instruments which have similar range. So it's with French horns and trumpets in B flat, and trombones which are tuned in B as well. I have the tritone of range of those spectral notes. So from B flat to E natural, all of those instruments have that. So I can move in this range very flexibly. And then I get this, and I can control this very nicely over my interface. And once I get to the real result in maximum speed, and I transport it, and very quickly I have this picture. And this might look a little bit scary at the first glance.
Not at all.
But
readable, absolutely.
But brass players would exactly. I mean, they are warming up with things like that.
Exactly. Yeah. That looks absolutely readable.
Yeah. So that would be one example from my patch.
Very
so
clear.
let's go on in the score. So let's see some other similar. These are kind of pizzicato clouds. I'm creating at the same principle with kind of arpeggi I was showing before. Yeah. The violin which plays here, I would do with the patch or just enter it manually if it's simple enough. Yeah. So I don't need my patch for everything. Just for structure, which just
this is solo
save
violin.
time.
Solo violin.
This is solo violin, so a lot of this takes time, you know. The arpeggio you can see here very well. This brass you have seen before.
This is fantastic.
So if you know my music a little bit, then you can see these structures how they're being made. As we have seen the raster of the notes, 16s, triplets, that's absolutely playable.
Absolutely playable, readable.
Yeah, exactly.
So this, I must say, to conclusion, if it's possible, to say that just to imagine that, yes, it is written on computer, not because it is for simplicity for you, but it is for simplicity also for musician to read your idea, which you had already in your mind. So it actually makes it just saves a huge amount of time for composer. This is absolutely fantastic one. So as the conclusion for entire explanation of your patch, I wanted to say that this is absolutely marvelous and fantastic way to present music to musicians, and it's absolutely readable, and it's not just composed by computer. It is your toolbox which helped you to deliver your ideas, which are absolutely great. I really always enjoy playing your music. Thank you for coming and explaining your patch.
Thank you for inviting me. It was my pleasure.
Thank you.